Hello, the listener. This is M. Salman Enterprise. From the last lesson, we have learned about statement number 2 from the sequence status control circuit. And in this lesson, we will learn about statement number 3 from the sequence status control circuit. So, we will read the statement together and explain it. So, the statement starts by saying motor 1 must be started before motor 2 can be started. So this statement simply means we must start motor 1 first, in which we will be able to start motor 2 after. So in other way, it says motor 2 shouldn't start first, but must only be started when motor 1 has started first. Right. Statement number 2, it says motor 2 can now be stopped and started without affecting motor 1. So this statement simply says we must stop motor 2, in which it shouldn't affect motor 1 to stop running or be de-energized. And also, when we restart motor 2, it shouldn't affect motor 1 to be off or to be de-energized. So from the statement number 3, it says if motor 1 is stopped while motor 2 is running. So I'll explain until the comma. So it says when we stop motor 1, motor 2 must keep on running. And then after the comma, it says motor 1 cannot be restarted unless motor 2 is stopped. So since motor 1 and motor 2 were both running, right now we have only stopped motor 1. And then when we try to restart motor 1 again, it shouldn't allow the sketch to be to allow the coil of motor 1 to be on. So it must only allow the coil of motor 1 to be on when the coil of motor 2 is off. So right now, my both coils are off, and then when I press the start button of motor 1, it switches on, and then when I press the start button of motor 2, it switches on. I press the stop button of motor 1, it switches off. I press the start button of motor 1, it doesn't allow to switch on, but when I press the stop button of motor 2, it switches off. Motor 2 switches off, and that's when it allows motor 1 to be restarted again when I press the start button. So that's what the statement simply says. Right, from the last statement, it says emergency stop button must stop both motors at any time. So when I press the emergency stop button, that's when it will create an open contacts in which it will de-energize every connection after the emergency stop, which is the connection of motor 1 and connection of motor 2. So both motors will be de-energized. Right. Right now we will draw the sketch together. So from the sketch, we must remember that we must start with our supply voltage. So from our supply voltage, we have live 1 and live 3. So remember, when we have live 1 and live 3, is because of in live 2 we have an ammeter that is connected to live 2 from the main circuit of sequence status. So that's why we have used live 1 and live 3 to be our three-phase supply voltage. Right. So we will draw the basic sketch that we have showed you from lesson 2 and lesson 1, and then that's when we will stop. We will draw until the stop button of motor 1, and that's when we will start with the statement and put it on the sketch. Right. So there is our basic sketch for all the sequence starters in the control circuit. Right. But if you can check from the statement, from statement number 1 until statement number 2, let's read it together. Motor 1 must be started before motor 2 can be started. Motor 2 can now be stopped and started without affecting motor 1. If you can check, these two statements is the same statements that we did from statement number 1 and statement number 2, sequence starters control circuit. So we will draw the sketch until statement number 2, and we will start explaining from statement number 3 all the way to the last full stop. So for you to understand statement number 1 and statement number 2, you must check the previous lessons from statement number 2 and statement number 1, sequence starters control circuit. So we will draw the sketch of statement number 1 and statement number 2. Right. So from this sketch, we drew it from statement number 1 and statement number 2. So we will continue from sentence number 3. Sorry, it was sentence number 1 and sentence number 2. So we'll continue from sentence number 3, in which says if motor 1 is stopped while motor 2 is running. So it says we must stop motor 1 and motor 2 must keep on running. So also, if you can check this statement until the comma, is the same statement that we did from statement number 2, in which we have started motor 1 and started motor 2 after, and when we have stopped motor 1, motor 2 uh, uh, must be energized, must keep on running. So in which means we will draw that contact until the comma, in which when you want to understand it better, you have to check statement number 2 on how we have created that contact that will stop motor 1 and let motor 2 to keep on running. Right. Okay, there is our contact that we have added. That says if motor 1 is stopped while motor 2 is running. So when we stop motor 1, motor 2 will keep on running with this contact. So from statement number 1, number 2, and number 3 until the comma is the one that we did from the previous statements. So we'll continue from after the comma that says motor 1 cannot be restarted unless motor 2 is stopped. So we will start by operating two motors, motor 1 and motor 2, and then we will stop motor 1, in which should let motor 2 to keep on running. And then we will try to restart motor 1 again and see if it will start or it will not. But from the statement it says motor 1 shouldn't restart again, but it should only be restarted when motor 2 is also stopped. So we'll do the process with you. So I'll start by turning on my 1M circuit breakers, in which they'll create close contacts. Right. So right now my current from the supply voltage will flow down and finds close contacts of 1 amp circuit breaker and flow all the way to the live 1 point from the voltage, and from live 3 it will go down and find close contact of 1 amp circuit breaker and goes down and all the way to live 3 of the voltmeter. So the reading between live 3 and live 1, it will give us 400 volts. So again, our current will flow from live 1 and finds close contacts of a circuit breaker and flows down all the way to the overload 1, and which is normally closed, in which current will flow, and finds overload 2, normally closed, current will flow, finds emergency stop, normally closed, current will flow, and current will flow down to the stop button of motor 1 and finds it close contact, current will flow, and current will flow all the way to the start button and finds it normally open, which means current will be trapped here, and also current will flow all the way to the return of motor 1 and finds it normally open, which means current will be stuck here. And then from here, current breaches again all the way to the contact of motor 1 normally open, current will be trapped here again, and also current will be trapped here in the contact of motor 2 normally open. So our current is trapped from 4 points, this here, 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 and here. So since well here it is trapped before the start button, it means it allows us to press the start button. So the start button will create close contact. So when it create close contact, current will flow all the way to A1 of coil of motor 1, and then from A2 current will flow all the way to the circuit breaker of 1 amp and finds it close contact, and all the way to the uh, live 3 supply voltage of live 3, and in which right now my coil will have 400 volts and be energized, in which when it's energized it will be is on, energized is on, and when it's on it will affect its contacts. Here it will be closed, and then also this contact of motor 1 will be closed. It will affect all the contacts of motor 1 to be closed. Here is closed and here is closed. So I let go of my start button of motor 1. When I let go the start button of motor 1, it will create open contact. It will create open contact, and which means right now coil of motor 1 will still be energized because of the return of motor 1 will let the current from live 1 to flow all the way to A1, and also it will have live 3 from A2, so it will still be energized. So since well my two contacts are affected of motor 1, from here, since well it is normally closed, current from live 1 will flow all the way and finds it with close contact, in which means current will flow all the way to the stop button of motor 2 normally closed, current will flow all the way to the start button of motor 2 and finds it normally open, current will be trapped here, and current will also flow all the way to the return of motor 2 normally open, and current will now be trapped here and here. So when it's trapped here before the start button of motor 2, it allows us to press the start button of motor 2, in which it will create normally closed contact, and when it creates normally closed contact, current will flow all the way to the A1 of coil of motor 2, and from A2 it will also have live 3 that will pass through the close contact of circuit breaker. So when my coil of motor 2 has life 1 and life 2, that's when it will be energized. So I'll write on. So when it's energized, it will affect its contacts. So the retainer will be closed and the contact of motor 2 will be closed. So it only affects the contact of motor 2. So right, I'm letting go of my start button of motor 2 since, well, the coil has energized and did this process in which it will create open contact. So my start buttons are open contacts, but the coils are still running through the retainers. Right. So right now my two coils are energized, and then from statement number 2 says motor 2 can now be stopped and started without affecting motor 1. So we need to stop motor 2 and start it again, in which it shouldn't affect motor 1. Right, I press the stop button of motor 2, which is here, creates open contact. When it creates open contact, everything after the stop button will not get the life 1 from the supply voltage. So in which means the coil of motor 2 will not get life 1, so it will be off. It will be off. So when it's off, it will affect these contacts. This one will be open. This one will be open. But when it's open, let's check if it has affected motor 1 to be off. So from the motor 1, let's check if it gets life 1 and life 3. So from life 1, current flows down here and all the way and finds the retainer of motor 1 closed, and all the way to A1, and from A2 also gets, from A2 it also gets life 3. So it's still energized. It didn't affect motor 2, motor 1 to be off. So we must start motor 2 again and check if it will affect motor 1 to be off. So I'm pressing the start button of motor 1. So right now it creates close contact. When it creates close contact, current will flow all the way to A1. So life 1 will flow all the way and finds close contact of motor 1. Current will flow all the way and finds normally closed off stop button, because of after I've pressed the stop button, when I let it go, it creates close contact again. So it will no longer be open, so it will go back to close contact. Right, when it's closed, current will flow here and finds open contact, and when I come here, uh, contact of motor 2 will be closed, and that's whereby motor 2 will get life 1, and from A2 it will get life 3. So I've started motor 2, which is on. So when it's on, it has affected its contacts. It's closed, and here from open is closed again. So right, I'll erase this process in which we will continue from statement number 3 all the way. Right, we have did our process from sentence number 1 until sentence number 2, in which we have ended up having both coils being energized, or both coils are on. Right, we'll continue from statement number 3 that says if motor 1 is stopped, while motor 2 is running. So we will stop motor 1 and see if motor 2 will keep on being energized. Right, I press the stop button of motor 1, in which it will create an open contact from the stop button of motor 1. And when I press the stop button of contact of motor 1, and everything after the stop button of motor 1 won't get the life 1 from the supply voltage. So which means coil from A1 won't get the life 1 from the supply voltage, but will only get uh, life 3 from the supply voltage. So in which means the coil of motor 1 will be off, and when it's off, it will affect its contacts. Retainer will be open, and then the contact of motor 1 will also be open. But let's check, since coil of motor 1 is off, let's check if it has affected uh, the coil of motor 2 not to get the current from life 1 and the current from life 3. So let's start by checking current from life 1. It will flow down and finds close contact of circuit breaker and finds close contact of overload 1, current will flow, finds close contact overload 2, current flows, emergency stop close contact, current flows, and current flows all the way, and here all the way to contact of motor 1, and finds it open, which means current cannot flow there, but current can also bridge down and finds close contact of motor 2, which means current will flow all the way to close contact of stop button of motor 2, finds it normally closed, current flows. From here, start button finds normally open, which means current cannot flow there through the start button, but current also bridges to the return of motor 2 and finds it normally closed, current flows, and all the way to A1 of coil of motor 2. But let's check from A2. A2, it also gets life 3 because of current will also pass through the close contact of circuit breaker. So which means coil of motor 2 still has life 1 and life 2, so it's still energized. So from statement number 3 until the comma, the statement is right. We have stopped motor 1, in which it didn't affect motor 2 to stop. Motor 2 is still running. Right, from after the comma, it says motor 1 cannot be restarted. Let's just wait there, wait says motor 1 cannot be restarted. So since we have stopped motor 1, which means it's off, let's see if we can start it again. If it can allow us to start it, it means the statement is wrong. We must uh, uh, create a contact that will disturb the coil of motor 1, the start button not to restart again. So right, I'm testing my start button. Current from life 1 will flow and finds close contact, flow finds close contact, flows, finds close contact, flows, finds close contact, flows, finds close contact, flows, finds open contact here, and here finds open contact. So when I've open contact before the start button, it allows me to press the start button. When I press the start button, current will flow all the way to the A1 of coil of motor 1, and it will also get life 3 from A2, which means it will be energized. So it means is the sketch is wrong because of it allows the start button to restart motor 1. So this statement simply means when it says motor 1 cannot be restarted, it simply means we must disturb the start button of motor 1 not to restart. So this is the start button of motor 1. This is the start button of motor 2. This start button is the one that energizes the coil of motor 1, and this start button is the one that energizes stop button of motor 2. So which means this is the start button of motor 1. We must only disturb the start button of motor 1, not to let the current flow all the way to 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 coil of motor 1 from A1. So when we should only disturb the start button of motor 1, not to let the current flow after we've pressed it, it simply means we must only disturb the start button of motor 1, but not the start button and the retainer. So when I put the contact here between the coil and the connection of start button and connection of the retainer, when I put the contact here, the contact, it affects the life that is coming from this wire and also this wire. So it simply means when we disturb only the start button of motor 1, we must create a contact after the start button of motor 1, which will be here. So when we create a contact here, it will only disturb the start button of motor 1, but it won't disturb the retainer, because the retainer will still flow here because of the contact will be here. So since well the statement says motor 1 cannot be restarted, we only disturb the start button. So remember, when we press the start button, it creates close contact in which it will allow the current to flow all the way to A1. So when we disturb it, we must have a contact that will trap the current after we press the start button of motor 1. So when the contact is normally closed, obviously when I press the start button, current will still flow. But when we create open contact, when I press the start button, current will be trapped here before the open contact, in which means when we disturb it right now, we will have open contact. Right, there is our normally open contact that disturbs the start button of motor 1, not to restart the coil of motor 1 again. But right now we don't know if this contact of normal open, we don't know if it's for motor 1 or motor 2. But let's check from our statement what it tells us. So it started by saying motor 1 cannot be restarted. Okay, we have disturbed motor 1 not to restart with a normally open contact after the start button of motor 1. So it also says motor 1 cannot be restarted unless motor 2 is stopped. So if we can listen to this statement, it creates a contact by itself. It says motor 1 cannot be restarted. So disturb motor 1, we have disturbed motor 1, unless motor 2 is stopped. Unless motor 2, so it tells us that it must only the contact that disturbs motor 1 must only be triggered by motor 2, might only be triggered by the coil of motor 2 when it's stopped. So it tells us that the contact must disturb the start button of motor 1 with a normally open contact unless contact of motor 2 is triggered, which means is the contact of normal open is for motor 2. That's what the statement tells you. But for you to understand it better, we won't start by saying is motor 2. That was the other way of showing you how to understand the context better by understanding what the statement tells you. But we'll start by testing the contact with you with motor 1. Let's just start by testing with motor 2 and see if it makes sense. So if it makes sense, you must understand what the statement tells you, and tells you how to create a contact. Right, let's start with motor 2. So at first it said motor 1 cannot be restarted. So when I press the start, okay, current from life 1 will flow down, finds close contact from circuit breaker, flows down, close contact overload 1 flows down, close contact overload 2 flows down, close close contact emergency stop flows down, close contact stop button flows down, and now current is trapped here, and current will also be trapped here because we have normal open contact of return of motor 1. So when the current is trapped before the start button, it allows us to press the start button. I press the start button, current flows and be trapped before the normal open contact of motor 2. But they say uh, motor 1 must be energized when motor 2 is stopped. So to energize motor 1, we must stop motor 2. So let's stop motor 2 and see if it will allow us to start motor 1. Right. So when we want to stop motor 2, we must press the stop button of motor 2 so that it can stop motor 2. So I press the stop button of motor 2. It creates open contact. When it creates open contacts, everything after the stop button of motor 2 won't get the live current from live 1. So it means right now my coil of motor 2 won't get live 1 because we have normal open here, won't get live 1, but will only get live 3. So which means coil of motor 2 will now be off, and when it's off, it will create all the contacts of motor 2. So where is normally closed, it will become normally open, and where is normally open, it will become normally closed. So right here, it will, since when it's closed, it will be open. Here is since when it's closed, it will be open, and here is open, it will be closed. So right, I've switched off motor 2, but let's see if right now the sketch will allow us to energize the coil of motor 1. So my current from live 1 will go down, finds close contacts of overload 1, close contact overload 2, close contact of emergency stop, close contact of stop button of motor 1, and here it will find open contact of start button of motor 1, and also to the retainer it will find open contact of motor 1. So which means right now, when we current is stuck before the start button of motor 1, it allows us to press the start button. I press the start button of motor 1, it creates close contact. When it creates close contact, live current from live 1 will flow and finds close contact of motor 2, which means right now current will flow all the way to A1 of coil of motor 1, and then from A2 it will also get live 3, which means right now coil of motor 1 will be on. And then when coil of motor 1 is on, it will affect these contacts. Open will be closed, so it's no longer open, but is closed. So also the contact of motor 1 here, it will no longer be open, but closed. So which means motor 1 has been energized after motor 2 has been de-energized. Motor 1 has restarted after motor 2 has been de-energized. So that's the statement until this full stop. So from the last statement says the emergency stop button must stop both motors at any time. Here's the emergency stop. When I push the emergency stop button, it will create open contacts, and everything after this emergency stop button will not get the live current from live 1. which means mode 1 and mode 2 will be off. Right. Yeah, after the emergency stop, mode 1 and mode 2 will be off. This one was already off. Right. So that's it about statement number 3. So the thing that you have to understand in statement number 3 is by understanding what the sentence tells you. These sentences here, they create contacts for you. Some they create contacts, and some they are telling you how to operate the contacts that are already there, or the components that are already there. So from the sentence after the comma whereby it says mode 1 cannot be restarted, it simply means we must disturb only the start button of motor 1. Only the start button of motor 1, not to let the current flow all the way to the coil that it must energize. So yes, that's how you disturb the contact. That's how you disturb you have disturbed the coil of motor 1 not to be energized with a normal open contact. So we are happy we have disturbed the start button of motor 1 not to restart again, but only to restart after motor 2 is stopped. So that contact that will disturb the start button, it tells you that it's for motor 2. That's how the sentence creates the contacts. Right. Thank you for learning with us. I hope you'll understand better. Yeah, see you in the next videos. Please keep on subscribing, liking, recommending our page, M. Solomon Enterprise, or at manmade 1983.